Welcome to Part 5 in this series of presentations on the drying of fruits and vegetables. In this presentation, we will examine food safety and quality. My name is Don Mercer, and I am with the Department of Food Science at the Ontario Agricultural College, University of Guelph. We will begin with several acknowledgements. Then I would like to go through a disclaimer which will follow with an introduction. We'll take a look at food safety in terms of a brief definition and then move on to food quality. Once we've looked at the factors influencing food quality, we'll revisit the subject of food safety. One of the questions that we have is our food safe to eat? And we'll look at that in light of the information that we've gone over in the rest of the presentation. Then we'll take a look at record keeping and code dating and wrap up with some summary comments. I would like to thank Mr. Andrew Goodwin, Associate Industrial Development Expert with the Agribusiness Development Branch of the United Nations Industrial Development Organization, for his considerable efforts in coordinating this project. I would also like to thank those who are assisting in the presentation of this material to various local groups. Their contributions to our training activities are greatly appreciated. We are now moving into an area of food processing where there may be regulations established by individual countries and various jurisdictions. As such, I am not in a position to assume any responsibility for incorporating these laws into a presentation of this nature. Ultimately, it is the responsibility of the manufacturer to make sure that all the guidelines and regulations are being followed as they pertain to each individual case. The material in these presentations is intended to provide an overview of the various aspects of food processing and drying. The author assumes no responsibility or liability for any problems of any nature encountered through the application of the principles discussed here. This material is intended for instructional purposes only. Now let's move on to the introduction. Food drying is a large and somewhat complex topic to cover in a series of short presentations. In previous presentations, we have examined the reasons for drying and how we dry food materials, as well as looking at the mechanisms of drying and the factors that influence it. Before we can get into the actual preparation of materials for drying, there are several aspects to consider. They are safety, quality, and sanitation. And sanitation will be the subject of a separate presentation to follow. Looking at things from a purely practical point of view, there is absolutely no sense in even beginning to dry food materials if you cannot do so in a manner that produces high-quality products that are safe to consume. In this presentation, we will describe the differences between food safety and quality. These are terms that are often confused or blurred together. We will follow this up by examining the role of sanitation in the next presentation. So here is a brief definition of food safety. Basically, a food is safe to eat if it does not make you sick or cause harm, and if it does not have any adverse or undesirable effects on your health. We'll leave it at that for a while and come back to it after we take a look at food quality. And as you can see, this is a very simplistic way of looking at safety, but I think it's quite effective. Most people would agree that the safety of the food we eat is extremely important. However, when consumers are selecting food to eat, they often confuse safety with quality. Even though there may be a degree of overlap, safety and quality are two different things. Let's begin by explaining what quality really is before moving on to explore it in any greater depth. Food quality is generally an impression consumers have indicating that the material meets a set of standards they have developed. So really, they have a checklist of items that they're going to go through, and as they see the material, they mentally check them off one at a time. These standards are often based on judgments pertaining to their five senses. We have sight or vision, touch or feel, the sense of smell, taste, and hearing or sound. Collectively, these are aesthetic items which appeal to our senses. Others will be added later. Quality is often subjective, depending on the preferences of the consumer and the desired end use of the material. Quality is an overall or general attribute that makes a food material desirable or undesirable to consume. Opinions about quality can differ from one consumer to another. So let's take a look at some of the sight or vision aspects. First of all, we have appearance. We look at these bananas and they look reasonably appealing. However, if we look at this banana on the right, it's not nearly as appealing from a visual perspective, and we won't likely purchase it. Color is another attribute. Here we see 3 hot yellow peppers, which actually have a greenish tinge to them, but with time they will turn to this red color. It's up to you to see which color you prefer or which level of maturity you want to have. In the case of touch or feel, we can look at firmness. We look at this carrot, and because it's firm, it's acceptable. However, if we have a carrot that you can bend like this, it's not quite as acceptable. And also, many people will look at melons and they will test them for firmness by squeezing them or thumping on them with their knuckles. We need to look at texture as well, and that's something that we can attribute to foods such as yogurt or other things like that. Smell is another one of our 5 senses. I think you'll agree that aromas can be very appealing, such as smelling a rose or smelling cinnamon and other spices. Ginger is very appealing, and also the smell of fresh berries can be very appealing. However, we can have offensive odors which are not nearly as pleasant, and this can be the case with spoiling food. Taste aspects can be divided into a number of categories. When we look at flavor, we can say something is sweet, or it might be salty, or it could be sour. We also have bitterness, and a new flavor aspect is umami or savory flavor. We have mouthfeel that can affect our perception of taste, and various attributes there would be things like, is the material smooth? Is it slippery? Does the pudding or whatever it is have a certain thickness to it? Does the material crumble in our mouth? Is it hard? Plus a host of other attributes that go along in the mouthfeel category. And finally, we have aftertaste. That's the taste that is left in your mouth after you swallow the food, and it can be pleasant or it may be unpleasant. Surprisingly, hearing or sound aspects can also apply to food quality. Crispness or snappiness can be applied to such things as carrots. If we break it, does it snap? When we bite on an apple, does it have a crispness or a snappiness and give us the sound that we are looking for as our teeth move through it? This can be related to texture as well as mouthfeel. Other factors that relate to quality can include perceived nutritional benefits. We might ask the question, is this good for me? Or is it good for my family? Moving on, we can also expand this question to look at the perceived health benefits. Essentially, the same questions will be asked as for nutrition, but there will be a few extras. These will include things like, will this make me feel better? Or is it good for my body? Functional properties of ingredients are also important. What is the fiber content that it has? Does it have antioxidant contents for good, healthy eating? Are there beneficial microorganisms present? And a category that is now coming into prominence is it free from? Is it free from additives? Is it free from chemical fertilizers? Is it free from pesticides? Is it organic? And the list goes on. We also have other attributes that I may not have listed here, but you can certainly identify things that pertain to quality in your own mind. Sometimes the choice is obvious. There are a number of factors that influence food quality. Among these are the raw materials that we use. Growth or production can be important, as I've shown by this example of bananas grown in the Caribbean. We also have to look at shipping and handling of these raw materials and the warehousing and distribution of them. This is what the consumer wants, so we have to make sure that the bananas reach us from the tropics in a form that will appeal to the consumer's perception of quality. And there are other items for sure that could be added to this list. Moving on, we need to look at processing and its influence on quality. Processing conditions will certainly have the major impact. High temperatures can create cooked flavors in juices, so what we see here is actually a person thermally treating juice by boiling it over an open fire, and once this is done, the flavor of the juice has diminished considerably. Then we need to look at the shipping and handling, as well as the warehousing and distribution of these products after they are processed. And once again, there are other items that you may want to add to this list. These lists are not meant to be all-inclusive, but just to give you examples of some of the aspects we need to consider. Looking at packaging, we find that it is a part of processing, but there are additional aspects to consider. We need to look at the barrier properties of the package that enable it to protect the product from outside influences. In this case, we see the plastic bottles that the juice that was being boiled over the open fire was packaged in. The integrity of the package is also important because that's what will contain the product, and if the package deteriorates with time, it certainly is not protecting the quality of the product in any way. We can also take a look at the environment. That includes warehousing and the distribution of the material over different conditions of roads and extreme distances. Here you see an example of melons piled extremely high on the back of a stake truck. In order to prevent the melons from being damaged by the side rails, they've actually put straw along the side. And after being carried over long distances on bumpy roads, the quality of many of these melons was diminished. We then need to look at the environment in the marketplace and the way the material is stored and used in-home when the consumer purchases it. Continuing on with the environmental aspects, we have environmental conditions such as time. The time over which the material is held in certain environmental conditions can have a pronounced effect on the quality. We look at the temperature of the storage. Is the temperature excessively high, which will accelerate decomposition, or has it been chilled, which will help maintain quality? What is the humidity in the environment? And here you see a small meter that is designed to record the temperature, which is 22 degrees Celsius in this case, and the relative humidity in the air, which is 54%. Most food products have an optimum set of conditions in which they should be stored, and you need to be aware of that in order to maximize the shelf life and maintain the quality. We need to look at light. In particular, sunlight can have negative effects on the quality of a product. And of course, there are probably others, as I've said before, that you can add to these lists that we are making. Preparation of the food can impact its quality greatly. Did the consumer adhere to the instructions when they made this particular dish from the noodles and the dried spice blend that we showed in a previous presentation? Were the conditions of preparation proper? Was everything observed in the way of cleanliness and temperatures and all those other things that go hand in hand with our expectations of producing a quality end product and making a meal for our family? What was the handling like during preparation? Did everything follow basic rules of sanitation? Were all the surfaces clean? And the list goes on. Then we look at the conditions of consumption. Those could include a number of things, including the temperature at which the material was consumed. If there are any leftovers, were they stored properly? And when it came time to use these leftovers, were they prepared properly? In most cases, the manufacturer will only have control of the processing, warehousing, and distribution. Unfortunately, processors are judged on the quality of their product at the time of consumption, even though the product has been outside of their control for much of the time. So quality control after the product leaves the sphere of influence of the manufacturer is actually non-existent. Now let's get back to food safety. As stated previously, safe foods are those that do not produce negative health effects when they are consumed. We can look at factors which impact the safety of food in 4 basic areas. The areas of food safety concern physical aspects, chemical aspects, microbiological aspects, and allergenicity aspects. Anyone who processes food materials must be aware of these and take steps to avoid problems relating to them. A potential cause of safety issues in these areas is contamination at various points along the food processing chain. Let's take a look at each of these areas in terms of contaminants that would threaten food safety. First, we'll look at physical contamination. Physical contamination usually involves the introduction of foreign materials into a product. Examples would include such things as metal objects, nuts and bolts from equipment, or even coins and wire, and maybe small stones, etc., from harvesting. Ideally, there should be safeguards in place to detect many of these. Metal detectors are an example of this. Screening may remove other physical contaminants, and large strainers or screens in an industrial environment work much like kitchen strainers to remove lumps and other small particles that may be present in liquids that we are preparing in the kitchen. Glass is a major concern. Glass is something which should be kept out of all processing areas except for packaging, since there is little that can be done to detect it. The effect of broken glass, if ingested, can be devastating. Now we'll move on to chemical contamination. As the term implies, chemical contamination is caused by the introduction of chemicals into the product. These chemicals are often harmful if consumed, but in reality, any chemical or ingredient that is present but should not be there is really a contaminant. For example, a product may not normally contain a certain colorant or protein material. However, if that colorant or protein is unintentionally present and got into the food accidentally, it may cause an unsuspecting consumer to have an allergenic response. And of course, there is going to be a degree of overlap here between a number of the categories. There are other sources of chemical contamination as well. Improperly stored or handled insecticides or herbicides may get into the process and create widespread problems. Another example is cleaning chemicals that may be spilled into the product. Processing lines and surfaces may not be properly rinsed after cleaning, and any residual chemicals can then enter the product. Now let's take a look at allergenicity before we discuss biological contamination. Allergenicity is now recognized as a major threat to food safety. As mentioned previously, there are individuals who have severe sensitivity to certain compounds which can be found in food products. Most of the time, people with food sensitivities and allergies are able to manage the situation by examining ingredient lines on product packages, which often have cautionary notes saying that the product may contain various proteins or milk products or other things which have been identified as causing allergenic responses. The real risk to their health and safety comes when there are undeclared compounds present. As an example, eggs are a common food material around the world. However, if eggs are accidentally added to a product that does not normally contain them, and they are not declared on the ingredient line, a susceptible consumer may have a severe allergenic response to them. Peanut allergies are another example. Individuals may go into anaphylactic shock from exposure to even trace amounts of peanuts or peanut oil. Consider a process that is used to prepare a product that contains peanuts or other nuts. If the process is not cleaned properly and is used for another product, there can be residual traces of peanuts or the other nuts left in the process that will enter the new product. This can impact those with nut allergies. As a result, many facilities have declared themselves to be nut-free. Biological contamination is probably the biggest threat to food safety, and that's why I have left it till last in the list to cover. It includes microorganisms, insects, and rodents, as well as other sources such as birds. And you'll notice I've actually used a cute little toy mouse rather than showing you the real thing. We often associate biological contamination with food spoilage. Things like mold growth may be easy to see, or we may detect the presence of other microbial contaminants through off odors, and the smell test is quite reliable. However, this is not always the case. There are dangerous microorganisms that may be present at very low levels that can create serious health problems if ingested with the food we eat. Some of them produce dangerous toxins. It is not possible to go into all of the potential biological and microbiological contamination sources in a short presentation such as this. There are numerous methods of reducing the risk of microbial growth in food products. Drying is just one of these methods. Other methods include thermal processing and the use of additives, as was discussed previously. Everything must be done in a food processing facility to ensure that the risk of microbial contamination and microbial growth is minimized. Much of this can be addressed through basic sanitation and safe food handling. And once again, I'll mention that we are going to discuss basic sanitation as the subject of the next presentation in this series. We have now looked at quality and safety in some degree of detail. So the question now becomes, is it safe to eat? The answer is maybe yes, maybe no. So let's consider the examples of some mangoes to answer the question in a more satisfactory manner. This mango may have everything we want from a quality point of view. It may have a good appearance, the texture may be good, it may taste very sweet because it's got the proper level of ripeness, it may have a lovely aroma, and the list goes on. But it still may not be safe to eat. Perhaps the mango had fallen to the ground and was picked up from the grass where sheep or goats had been previously grazing. Animal droppings in the grass contain harmful microorganisms that can easily be transferred to the skin of the mango. Fruits that have fallen from trees are called windfalls, since they often fall during a heavy wind. Here is a picture of a windfall mango rotting on the ground. You should never use windfalls in your food processing, since they can easily pick up contaminants from the ground. Perhaps birds in the trees had left their droppings on the skin of the mangoes. Once again, harmful microorganisms could be present on the mango skin. Insects may have landed on the mangoes, which can transfer harmful microorganisms. They may even lay their eggs on the fruit. Perhaps the mango trees had been sprayed with an insecticide just a few days before they were picked. This would leave chemical residues on the surface of the mangoes. What we now have is mangoes with surfaces that may be contaminated with chemicals, microorganisms, and insect eggs that are not visible to us. You may immediately think that washing the mangoes will remove all these contaminants from the surface. This may be quite true. However, if the water is not drinkable or potable, then the mangoes could actually pick up things from the wash water. This is where strict attention to sanitation becomes extremely important. You may also want to keep in mind that fruits and vegetables don't always have to look perfect to be safe and nutritious. Misshapen carrots can be safe and nutritious to eat. They just don't look all that pretty. And unfortunately, I was unable to find some misshapen carrots to photograph for examples in this presentation. A significant amount of food goes to waste simply due to the fact that it is not perfect in appearance. Growers and merchants in some countries have addressed this problem by selling high-quality, ugly fruits and vegetables at a somewhat lower price than those that are more attractive. Before leaving the topic of safety and quality, we must consider record keeping and code dating. These are two critical aspects that bring together both food safety and food quality. We can conduct our record-keeping activities in written logbooks, or we may prefer to have electronic storage on disks or hard drives in computer systems. When producing or preparing a food product for sale or distribution, it is absolutely imperative that accurate records be kept for each and every batch of product that you manufacture. These records must be kept in a safe location for a suitable period of time. The duration of time depends on the nature of the product, but a minimum time of several years is not unreasonable. Records need to contain information about the product formulation, which will include the ingredients used, as well as the actual processing conditions. In order to link the records to the product itself, each batch of product must have a unique code. These codes frequently take the form of a code date. In this way, if there are problems with a particular batch of material, it can be easily identified and action can be taken. Code dates are extremely important in the case of product recalls, so that product can be identified and removed from the distribution system in a quick and orderly fashion. If there are any outbreaks of illness related to a batch of material, the code date can be used to trace that batch back to its time of production and ultimately the conditions that were used. Codes can take any form, as long as they enable the processor to link the material being distributed to the production records for that batch. They do not have to be something that the consumer can understand. So here is an example of a code that the consumer may not be able to understand. We have a series of numbers here, 7171-2128-B2. The manufacturer can look at this and gain a great deal of insight about the material, but the consumer might not understand it. So let's try and break this code. In this code, the first digit stands for the year in the current decade. 7 indicates 2017. The next 3 digits designate the day of the year. Day 171 is June 20th, so this product was produced on June the 20th, 2017. The middle 4 digits give the time of day the production was packaged or made. 2128 indicates 21:28 or 21 hours and 28 minutes on a 24-hour clock, which is 9:28 p.m. B2 could be an internal code that represents the packaging line or the facility where the material was produced. Often, however, the codes will do what we may think of as being double duty. They may also inform the consumer about the time frame during which the product should be used. This is a best before format that reflects the shelf life of the product. The shelf life of a product is generally considered to be the length of time between its manufacturing date and the date at which it would normally deteriorate to a point where its quality was falling below a level that was satisfactory to the consumer. Products are often safe to eat after their best before date, but this is a good guideline for the consumer. Here is an example of a best before date. This says best before JN20/18 21:28 B2. The consumer can easily tell that the product should be used by June 20th, 2018. The time 21:28 does not mean that the best before time is calculated down to the very last minute. This just lets the manufacturer know the time the product was packaged or made on its date of production. Once again, B2 is an internal code. The manufacturer can take the best before information and link it to the production records. If the expected shelf life is 1 year, the best before code will be dated 12 months after production or packaging. If the shelf life is only 7 months, then the code date will be set for 7 months after production or packaging. No material should ever be allowed to leave a processing facility without a code date printed clearly on its label or package. And here we see a code date on the side of this beverage. So in summary, now that we have discussed the differences between food safety and food quality, you should be able to identify the various aspects involving your products that affect safety versus those that affect quality. It is important to have both safety and quality in the foods we consume. Keep in mind that it is the responsibility of food processors to maintain complete and accurate records that conform to the rules and regulations in place in their countries. All products leaving a facility must be labeled with a unique code that makes it possible to link that material to production data. Anyone manufacturing food products has a responsibility to the consumer to deliver high-quality, safe food products. Thank you very much.